So just taking the first thing that comes to my mind as right now overrated. Right now, I think inequality is overrated. We're
Mm.
kind of obsessing about it right now since the financial crisis.
Mm.
And while inequality is important and injustice is a really, really important moral thing, right now everybody tries to frame everything as an inequality question,
Yeah.
which in many cases is beside the point. The medieval revolutions didn't happen because people said it was wrong for the king to be rich and the peasants poor. It was quite often because of some silly religious question. A
Mm.
lot of conflicts are not about inequality, but right now we have decided to frame them like that. And the problem is, of course, that given that traditional Marxism has kind of died a quiet death, people are not even very good at making a good argument about it. Not that I'm a fan of Marxism, but at least they had some kind of theoretical construction.
Mm.
So that is one of the things I think we're right now too often throwing into any discussion on any topic, rather than thinking about injustice or maybe poverty is a problem. When it
Mm.
comes to underrated, I think we are totally missing the tremendous explosive power of things being searchable and identifiable.
Mm.
And this might sound equally crazy
Mm.
because most of us probably find that, oh wow, the world has been changing, but I think we have seen nothing yet.
Yeah.
I had a great conversation with a friend who's a sociologist who spent some time talking to Google DeepMind, and
Mm.
we had this thought experiment. Suppose everybody who's doing anything in machine learning and AI never has any good ideas ever again.
Mm.
Then what? Well,
Yeah.
the technologies we have in the lab are enough to really change the world because we're on our way towards a world that is searchable, where most things are internet connected or have the little sensors, and it's possible to infer information from all these small pieces.
Okay.
So that means that you get a world where most pieces of information can be found out. You just need to ask the right question, which is still as hard as always.
Yeah. Yeah.
So a few years back, the science fiction author Charles Stross, he said at a phone conference that, oh, in the future, kids will never be lost, never alone, never forget. And
Yeah.
that's now we're in the future. We're essentially already in that state.
Yeah. Yeah.
Now, the really interesting and the fascinating thing about this is uh, in computer vision, there is this idea about the image manifold. This is a kind of explanation why computer vision has worked so well.
Mm.
So there is some kind of high dimensional structure to how the visual space works. Some
Mm.
of it is kind of obvious. We tend to see cohesive fields of color, and that corresponds to objects or parts of objects. It's not just random noise. It's a very
Yeah.
specific kind of input. And this is the reason some forms of vision works. But
Mm.
it might not be, of course, that we have a reality manifold. There is a structure to reality, and just by having a lot of searchability, you might get systems that are very good at mapping out this. Doesn't mean that they're intelligent or anything, but now you can do a lot of very mysterious new inferences about how stuff works.
Okay. That. Yeah. I think it is very. The whole thing about being searchable, I think, is very underrated. I do agree with you a lot. It's not something that I'd actually necessarily thought about a lot. Um, unless the only time when I've thought about searchability is when when you get old people who are like, oh, back in my day we would have looked that up in a encyclopedia, or we would have gone to the library and like read a book about it. And I think when people say that to me, I'm like, no, but you're missing the point. It's really nice being able to just sit down and instantly get an answer to a question, because by the time that I've gone all the way to the library, I'm not really that motivated to find out what that question is anymore.
But
Um,
that might be because we're so easily distracted these days.
yeah,
Back in the old days, you would have walked 5 hours to the library, spent 5 hours there, and then walked back over 5 hours.
yeah, yeah. Do you reckon because of technology we actually do end up thinking at a faster pace than if you would have done uh, back before you had the internet? So, for example, I know that um, for me now, with the level of exposure to technology that I've had, that um, I know that back in the day I wouldn't have bothered to go to the library. I would have just thought up something else and then something else, and then I'd have like a million items on the list to go and look at in the library. By which point I would be like, maybe not. I don't know. What do you think?
I do think the technology allows us to do very quick things, and that means that we also have an incentive to try a lot of different things. Because if I try one thing and it's not the best, I might quickly try several other things to try to see if any of these ones look better, and then switch to that one. So we try a lot of things at the same time. Now, people who are good at doing research, they also then, once they find the useful piece of information, then they carefully read it.
Yeah.
Otherwise, it's easy to just continue jumping between a lot of little sources.
Yeah.
So I think if you look at how old-fashioned researchers or thinkers were doing, since it was very costly to find out the information, we spent a lot of time thinking about a really good question. But we can actually get away with having worse questions, but we can refine them on the fly. I often start research having a rough idea what I want to find, look at a lot of instances and try to borrow a bit of a language I can ask a refined form of a question and gradually find what part of knowledge it is. So at the library, the problem would have been, is that information in an encyclopedia? In the day, I think in most cases you would only get answer in very, very narrow areas. We can get it much more broadly, but finding the names of what we're searching for is harder.
Yeah, especially if you don't, if you're going into a subject for the first time and you're trying to research it, you don't know all of the key terms that, like, different terminology or even what the literature would be around that subject, for example. Yeah, it must have taken ages.
Yeah, it did. To some degree, that was holding things back, even though I think people paid much more attention to the scarce pieces of information they could get.
Yeah.
We tend to be much more willing to throw away an uninteresting paper because, doesn't seem to be as promising as some other paper.
Yeah.
I quite often figure out new research fields just over breakfast, just quickly rushing through, getting a sense of what's in there, where should I be looking, is there anything here, or should I be nosing around in some other corner of cyberspace?
What has been your favourite part, like, what has been your favourite thing to research thus far? Because you've
most recently for my book project, I discovered that actually astrophysics is absolutely gorgeous and beautiful. I liked it before, but now I have a reason to try to organize some of its information and make use of it in slightly unusual ways. And that is so fun. Actually going through the textbooks, talking to astrophysicists and kind of figuring out this domain. But previously I was just leafing through the books and looking at the pictures of the results. Now I actually care how we reach the results.
Yeah, I do like astrophysics as well. It's a very I think the language that it uses, I think, is one, very visual, and two, it feels quite magical almost, but it's based on evidence and facts that have been discovered over time. But I find it very interesting when people seem to need to construct a supernatural when you can learn about astrophysics, which is based on evidence, and that is far more supernatural and weird than anything that you could have got in any sci-fi book, really. It's very interesting.
Sorry. So, for example, I discovered accretion disks around black holes are very effective in converting matter into energy. Now, I kind of knew that intellectually. I've been leafing past those pages, but never really paid attention until recently, when I really started reading and understood this is awesome. Here is a part of nature where basically, naturally, if just a bit of gas and junk gets close, you get something that's much more effective than many of our best engines today on Earth.
Yeah.
It's getting much more energy. and it just spontaneously forms when asteroids get close to black holes.
Wow, that is amazing. That would be such a good technology to have. That would be way better than a Dyson sphere around the sun or anything. If you could recreate like a mini version of that, you could just chuck anything in, and then you would be able to get a lot of energy. Yeah.
Yeah. So I actually been thinking about making Dyson sphere-like things around accretion disks of black holes. They need to be rather sturdy because there is so much energy, but they need to be heavy to hold back against just the pressure of the light.
Yeah, yeah. How heavy would that have to be? That would have to be unbelievably heavy.
Yes and no. My calculation said about 30 kilograms per square meter for a fairly big black hole. Because it still needs to stay far away from the black hole and the disk itself because they're too intense. But 30 kilograms per square meter, that's kind of a lot of metal. This is metal sheeting. It's not just flimsy aluminium foil floating gently in space. No, this is weighing down on the light, and the light is forcing it out.
That's really cool. You see, like, that's why it's stuff like that that really fascinates me. Honestly, it's just so fantastic and bizarre. And then people talk about ghosts and zombies, and you're like, come on! But this is so cool. It is really fascinating. Do you think black holes will become more and more relevant in the future in terms of research, astrophysics-wise?
I think we're getting very good telescopes now, so we're going to see so much. So black holes are going to be observed, but we're getting all kinds of objects now thanks to the Gaia satellite and hopefully the James Webb telescope. So it's the old objects, we're getting a lot of them, and then we're getting new objects too. So astrophysics is almost getting flooded by fascinating objects. Personally, I'm very fond of black holes because they are simple objects. They're in some sense simpler than even stars.
I mean, it's basically like a Hoover. That's all. That's all that's to it. It's just like a giant Hoover that goes around space, just munching up everything. Or maybe like my brother when he's really hungry. Like it's pretty much the same. But obviously not quite so much decay goes on. But or maybe it does. Maybe that explains a lot about my brother. Yeah. What particles have been particularly interesting? What's come up most recently that's fascinating?
So in particle physics, while I'm very fond of strange quarks, the really important cool ones are of course dark matter, which we still have no clue what it is. So this weekend I was on a panel with John Ellis, the eminent particle physicist, and he was seriously distracted. He had to glance at his phone now and again because there was a seminar at the Dark Matter Observatory in Italy that been kind of suspiciously scheduled. It almost looked like they had something important to say. It was a chance that this would be it. This would be a great announcement. Unfortunately, the SMS message he got from his agent in the audience was no.
Oh.
We didn't find anything. But we did a grand announcement of this.
It's a grand announcement of nothing important's happening. That is the great thing about science, is that people admit that they have no idea what they're doing, and they're more than happy to admit that I have no clue what is going on right now. And people are like, nice, write a book about it.
And you can even write a very careful, rigorous book about what you don't know.
It would still be scientifically accurate and very commendable, I'm sure. I almost want to do that as a project, like a list of all of the things I don't know about, and just, I don't know, maybe create an art piece about that. Kind of pointing out how science is very, very happy with not knowing stuff, whereas everything outside of that really wants to put meaning to a lot of things, and it's very difficult to do that without evidence.
Yeah. So in science it's fun. It's okay not to know something, but then it's like an itch. You really want to figure out ways of knowing it, even though it's hard.
Yeah.
In normal life, people don't want to admit they don't know what's going on, but we're not too keen on actually finding out what's really going on.
Yeah. It's kind of, that is very true. That people do just kind of want to be like, oh, okay, that's whatever. I'll move on to the next thing. Yeah. So, what is the most interesting thing that has been found in space recently?
Personally, I think it is actually the collision of the two neutron stars that was observed by the LIGO observatory. So already the gravitational waves, that was totally expected, but it was marvelous that we found them. And that already gave us surprise, because the black holes were larger than expected. People expect small solar-sized black holes and supermassive black holes, but these were middleweight. And nobody really knew what to make of them, and we still don't really know how to explain that. But the neutron stars are fun, because that also really demonstrated that, okay, we now understand where the heaviest elements on Earth come from. And that is from colliding neutron stars.
Yeah.
So I like to point out whenever I'm talking that, oh yes, my wedding ring of tungsten, haha, this was once a neutron star matter.
Yeah. That is very cool to think about. As well as, it was amazing when they discovered that there were gravity waves, like, so that they could categorically prove that, yes, no, gravity waves, that's a thing. We can now start exploring all of that sort of stuff more. I'm sure a whole load of scientists were like, yes, but also, no, we have to do a lot more research now.
It's always that the surface of the unknown increases when you explore, because now you get even more unknown to explore.
Yeah, well, you realise how much you don't know. That's the best thing. I thought I knew nothing, and now I really know that I know nothing, now that I know something. Yeah.
There is a very good scene in one of Terry Pratchett's novels where two wizards are discussing the nature of time, and one is trying to explain what's basically relativity theory to the other one. And it ends, of course, as always in Terry Pratchett stories, with both of them totally confusing themselves with mixed metaphors. But the discussion ends with both of them feeling very smugly knowledgeable about their ignorance. Because we don't know what we're talking about, but in a much better way than the lay people.
Oh, yeah, that's so good. Yeah. I feel that. I like, ignorance is bliss up to a point, but then the more you know, the more ignorant you realise that you are. Which...
Yeah. And there is this form of ignorance where you don't want to know certain things because it's distracting or disturbing. And I don't think that is true bliss, because you constantly need to be on guard of somebody spoiling the universe for you. And then you have ignorance where you just have a nice worldview that actually works. But most ignorant people also are not curious. If you're even the least bit curious, you will start pulling at the threads and start noticing all sorts of wonderful holes of uncertainty and lack of knowledge around our worldview.
Definitely. What do you think is the most interesting research that is coming up? Do you know if there's a research area over the next few years that is going to be particularly interesting? Anything that's opened up recently?
Right now, people are using deep learning to do simple chemistry. So they have trained neural networks and machine learning to do essentially the job of chemists. It's mostly doing very simple things that no chemist really wants to do anyway. But I think we're going to see a lot of kind of computer-aided chemistry over the next few years, which are probably going to be really interesting. The same thing I think is going to happen in biology. Computer-aided cell biology. not so much that you just do genomics, but you have a computer doing experiments or even exploring certain complicated functions. I think that is going to throw up a lot of really unusual and exciting stuff, but it's also extremely unpredictable.
Yeah, it is unpredictable, and also I guess if you're doing computer aided chemistry, either it will think in a way illogical to humans, so it will be able to come up with connections that other people may not have thought of, and also that I guess that you would be able to do chemistry experiments where humans would normally not be able to be present for. So, for example, working with really dangerous isotopes and all of that sort of stuff, is if it's a computer that's doing it, then it doesn't really matter. But if it's a human, then
Yeah.
it's not going to be much fun. So
there is a very nice set of posts on a chemistry blog called In the Pipeline that are headed Things I Won't Work With, which is about the worst molecules ever in chemistry, and some very hilarious descriptions about why they're so terrifyingly bad. I warmly recommend it. It's one of those hilarious but also very educational ways of thinking about things. I'm sending you one of the entries from the guy's blog. You can probably follow up. Let's see if I can find where I have the chat here. There it is. So he's got these fascinating stories about many of these really, really nasty chemicals.